Welcome to 44th lecture in the course of Industrial Engineering and Operations Research. We are discussing operations research, and in that subtopic is transportation models. We discussed that basically transportation model is also a linear programming problem, and solution method is similar to simplex method. We have to obtain initial basic feasible solution, and after that we have to optimize. So, we discussed various methods for obtaining initial basic feasible solution. We discussed north-west corner method, which is very simple method and it can be done very easily. That is why we teach it also first, that sometime you know that you can cross check or you want to verify. Nowadays computer codes are there, everything is done in the computer. So, these methods which are done with the help of hand calculations are mostly useful for some time verifying whether computer is also giving you right answer or not, there is a bug or not. So, therefore, you need some faster methods also, and north-west corner method is such type of method. There you keep allocating the quantities from sources to destination in a very systematic way. You need not pay attention what is the cost of transportation, you will get the solution. It is not dependent on the cost of transportation. Suppose cost of transportation is different in two cases, but the supplies and demands are fixed, then the solution will be fixed. But since we do not pay attention to cost of transportation, naturally that solution will not be optimal, although it will be very fast. Then the other method is least cost method, where we have to actually see it properly that what is the cost, and we first assign some item to least cost cell, and after that we go to other. So, mostly the basic principle of least cost method is that you give more units to transport from that destination to some means destination to source, rather source to destination, where cost of transportation is least. But now we are going to discuss one other important method which is more effective. In fact, it is likely to be more effective than least cost method, that is called Vogel approximation method. So, although it is expected to give more optimal solution, means closer to optimal solution, but it has to it takes time, okay, and you have to do it carefully. So, there are you have to make trade off, means there are pros and cons. You on one hand it will be very good method, but on the other hand it of course will take time. So, Vogel approximation method we will discuss, although there can be other methods also, but we are confining to only these three methods, that is north-west corner method you already studied, least cost method, and now Vogel approximation method. So, just see that the concept. So, for that we consider the same problem, that we say some special items are produced at factories at Patna, Guwahati, Mumbai and Hyderabad. This is written here. Distributors are located at Lucknow, Delhi, Jaipur, Chennai, Kolkata. Supply and demands of items are indicated in table. This is the supply. Patna supplies 3000, Guwahati supplies 6000. And note that the factories have capacity to produce 18,000 items. So, this is 18,000, 369, 413, 518. Demands are Lucknow needs 2000, Delhi needs 7000, Jaipur needs 4000, Chennai needs 1000, Kolkata needs 1000. This I have indicated in the table. So, total demand is 18,000 items. Sorry, the total demand is 15,000 items, but the supply is 18,000 items. So, naturally it is not balanced. So, you have to put some dummy destination. and load distances from factory to distribution centers are indicated in each cell. Your goal is to minimize the transportation cost, assuming that transportation cost will be proportional to load distance. So, therefore, here unbalanced problem. So, add dummy destination and this dummy destination has been added, cost of transportations are 0 and the total demand is 3000. So, method is that here also first allocate cells except dummy column and at last step in dummy column, that type of thing we can follow. Okay. So, for each row determine a penalty measure by subtracting the smallest unit cost in the row from the next smallest unit cost in the same row. Now, here we can consider that, for example, for row Patna the smallest unit cost is 0. Okay. So, here we have in fact considered this one dummy also. So, we say that here the penalty we say next smallest cost. So, how much is the penalty? So, this is 580 is the least cost because Patna to Kolkata, and then dummy is 0. So, therefore, row penalty is basically 580 minus 0. Okay. You can say like that. Here in Guwahati row we can say that least cost was how much? 1018 and dummy cost was 0. Okay, dummy cell. So, therefore, 1018 and Mumbai also in the similar way, Hyderabad also in the similar way, and in the demand in this column, destination column, Lucknow, in Lucknow this is 400 column penalty. So, that means 410 because here 1020 minus 610. Okay, 1020 is the maximum cost and second maximum cost is 610. So, penalty is 410. No, rather 1020 is the least cost and the 610 is the least cost and the second least cost is 1020. Okay. Similarly, here also if you see that 1060 is the least cost and second least cost is 1420. So, penalty is 360. You mean to say that suppose something is very low, but how much low it is in comparison to its neighbor. So, here 1150 is this one least and this is 1180. So, this is 30. See, this is the thing and like that, and it is 0 minus 0 is 0. So, therefore, we have got this type of thing, we got column penalty also. Okay. So, now identify the row or column with the largest penalty. Okay. So, wherever the penalty is more, allocate as much as possible to the cell with the least unit cost in the selected row or column. So, in this case the maximum penalty came out to be in this one, maximum penalty came out to be where that it came out to be in this one, row penalty 1150 we took. Okay, consider that thing. And then what we did that we are putting that actually maximum. So, in that particular row we want to allocate as much as we can do. Okay. So, we have their demand was supply is 4000 and but demand corresponding dummy demand is 3000. So, we just give 3000 to dummy cell. Okay. So, the dummy cell is getting 3000. Okay. So, in this case we have given to dummy cell first also, that is, but one can make this type of algorithm also, that one can say no, I will not give first to dummy cell and I will give dummy cell will be allocated later on, dummy cell will not participate that thing, but here we have done 3000 this one. So, maximum the maximum allocation in the cell we have done and 3000, this satisfies the entire demand of dummy and therefore, we have cross cut the column D dummy. Okay. So, dummy goes and now it, so actually dummy is not in the picture and it leaves 1000 units with Mumbai now in supply side. Now, step 3. So, then what next maximum penalty, now again you have to do the things that actually you may have to see that what is the next penalty. Okay, this is already gone and then we have to say next penalty is basically where is that, we have to see that 6 next maximum penalty is now 700. Okay. So, 700 means Chennai. Okay. So, in Chennai, that means in Chennai column you have to assign whatever you maximum you can assign. So, Chennai demand itself was 1000. So, we can assign only 1000 maximum. So, we are assigning 1000 here. Now, Chennai will not have any demand. So, therefore, that column has to be crossed. Okay. And demands are adjusted. In Hyderabad row 1000 it has supplied to Chennai, and therefore, its supply remaining is 4000, because earlier its supply was 5000. Okay. So, this is how that it has been done. Okay, fine. Now, this is also gone. Okay. Now, you may have to see that once these things go also, then penalties may also get adjusted, because suppose, by the way, suppose you would have here it was calculated, suppose in Patna row maximum was 610, least cost was 580, and Lucknow was 610. So, it was 30, but by the way Chennai should have been the second least, then naturally that equation will be different. Okay. So, that is why that this has to be paid attention. But anyway, let us go to the step 4, the next maximum penalty 438 is in column Kolkata. Where is 430 column Kolkata? Yes, 438 column Kolkata. Why? Because here the least cost was 580 and second least cost means above that 1018. So, penalty was 438. So, therefore, you will give maximum amount to this one Kolkata. So, Kolkata had anyway demand of 1000. So, give supply of 1000 from Patna. Patna had total supply 3000. So, now Patna remains at 2000, but Kolkata column is gone. Okay. So, this is what this has been done, and now once the Kolkata column gone, Kolkata was least cost, so this row's penalty will also be adjusted. Now, the least cost is 610 and second least cost is 1060, that means Patna Delhi. So, therefore, 1060 minus 600 450. So, here you have to, that is why the method takes more time. At each step you have to keep modifying the even penalties. So, penalties got modified, and this is the situation before you, and let us see what happens. Next maximum penalty is 890. Where is 890? Here, that in this one Kolkata column gone, next was something that here 890 row penalty. See, row penalty in the Guwahati row, it was the least cost was 1020 and Delhi was 1910, second least. So, 1910 minus 1020 is 890. So, therefore, this is happening that here that you will get that this one. So, we will try to allocate maximum amount to Guwahati row, but in the least cost column. Okay, 1020 was the least. So, you allocate maximum 2000, because although Guwahati can supply at this stage 6000, but demand at Lucknow is 2000 only. So, you can supply only in that cell maximum 2000, because 2000 is smaller than 6000. So, 2000 you supply to Lucknow, finish that thing, and remaining 4000 amount, 4000 units will remain with Guwahati. So, this goes, and then naturally the penalties are again adjusted. You have to see carefully that here, if you know there is need to adjust the penalty. See, here it was that Guwahati penalty was 890, but once I have allocated, so that 1020 cell has gone, and now the least cost is 1910. So, 1910 and second least cost is 1946. So, 1946 minus 1910 is 36 only. Okay. So, similarly other cases also it got adjusted. 450 became 120, this became 270, this became this one. You can maybe you can do it yourself, maybe you can pause the video and you can just calculate. Okay, that this is the thing. Delhi, of course, there is no change, because in Delhi thing we have not changed this one. So, here in Delhi column penalty is only 360 only, because 420 is the second least cost minus the least cost is 1060. Okay, so this is the thing. So now which is the maximum penalty here? Row penalty is 120, 36, 270, here 270, but here 360. So that means Delhi has got maximum penalty. So let us try to allocate as much as we can allocate to Delhi. That means because 360 is the highest penalty, but how much I can allocate? I have to allocate in 1060, because that is the least cell cost cell. So Patna to this one. So Patna can supply only 2000. So although Delhi can accommodate 7000, but Patna can give only 2000. So first give that 2000 at least to Delhi, and maybe Patna thing is now gone. Okay, Patna, because we have given already there, so Patna's supply is now 0, but this remains 5000. Okay, so we have to take 5000 from some other sources. We can go to those. So let us see that what happens in the next step. So here the next, as I said, the next maximum penalty 360 is in column Delhi, and the corresponding least unit cost is 1060. The maximum allocation in this cell Patna Delhi is minimum 2000, 7000, 2000. This exhausts the entire supply of Patna. That is Patna leaves with 0 unit, and cross cut the row Patna, and this leaves 7000 minus 2000, 5000 units with Delhi. And again you make the penalties, adjust the penalties like row penalty, whichever is the active one, whichever row or column is not dead or which has not been cross cut. So Guwahati, say for example, is there, Mumbai is there, Hyderabad is there, Delhi, Jaipur is there. Okay. So let us say that here I am seeing that the maximum row penalty is in Jaipur. So that means now you will allocate as much as you can give to Jaipur, that Jaipur column. So focus on Jaipur column, but you have to supply to this one only 1150, because this is the least cost in that column, that Jaipur column. And how much we can give? I can give 4000, but then the supply from Mumbai is only 1000. So you can give 1000 only, and this becomes 0, and this remains, Jaipur's demand still remains 3000, like that. So let us see that what we do. Yeah, so this is the thing. Next maximum penalty is in column Jaipur, and the corresponding least unit cost is 1150. The maximum allocation in this cell Mumbai Jaipur is minimum of 1000 to 4000. Now you have to see both supply and demand for that cell, and whichever is minimum, that much only you can give. So this exhausts the entire supply of Mumbai, leaves 1000 minus 1000 is equal to 0 unit with Mumbai, cross out the row Mumbai, and leaves 4000 minus 1000, 3000 unit with Jaipur. So this is the situation, and again you adjust, make the penalties. So you see that now if you make again the penalties, then the maximum penalty is with Jaipur. Okay, because in Jaipur column, now among the remaining cells, minimum cost is 1470 and maximum is 1946. So 1946 minus 1470, that means 476, and similarly in Delhi it will be this one, Delhi column it is 350, you can see that. So now I am trying to associate maximum unit to Jaipur. So in the Jaipur, now what will happen? This is 1470, this is 1946. So here minimum is 1470. So that means you try to give as much as you can give to Jaipur. So you see that in this cell 1470, Hyderabad is the supplier, but it can supply 4000 and Jaipur demands 3000. So let us give 3000. Okay, that means minimum of these two things, 3000 and 4000 is 3000. So 3000 can be given and Jaipur column can be crossed. Okay, so it is like that. So we have done the maximum penalty 476 is in column Jaipur, and the corresponding least unit cost is 1470. the maximum allocation in this cell, that means Hyderabad Jaipur, is minimum of 4,000 comma 3,000. So, this is 3,000. This justifies the entire demand of Jaipur. This satisfies the entire demand of Jaipur. Cross cut the column Jaipur and use 4,000 minus 3,000 is equal to 1,000 units with Hyderabad. So, this is done, and now again you put the penalties, and now you see the maximum penalty is coming in the row of Guwahati, I think 1910. So, therefore, whatever it has a supply of 4,000, we can see that, and here you have to see least cost cell, but actually only one is left out. So, it is, there is no, that one is least also, that one is the only cell. So, you have to give 4,000 only here, and this is 4,000. So, therefore, it is, you will give that 4,000 here, okay. This is 4,000, and then it will be remaining demand will be in Delhi 1,000, but this Guwahati row will go like that, it will be done. So, let us see that in neat and clean way. So, Guwahati next maximum penalty 1910 is in row Guwahati, and the corresponding least unit cost is 1910. The maximum allocation in this cell, that means Guwahati Delhi, is minimum of 4,000 comma 5,000, that is 4,000. This exhausts the entire supply of Guwahati, cross cut the row Guwahati, and it leaves 5,000 minus 4,000 is equal to 1,000 units with Delhi. That means Delhi still hits 1,000. So, then we are left with, now this is the low penalty maximum is in Hyderabad. So, that means you have to give to Hyderabad. We are left with this cell Hyderabad Delhi. The maximum allocation in this cell is minimum of 1,000 comma 1,000. This exhausts the entire supply of Hyderabad. So, Hyderabad is cut and satisfies the entire demand of Delhi also. So, cross cut this one. So, therefore, now it is complete. Now what happens, that we have already supplied and satisfied the entire demand of Delhi. So, we can even cross cut the column Delhi also now at this stage. So, therefore, what happens that because Hyderabad is also now 0. So, therefore, what happens, that we have done like this. So, we have reached the final initial allocation now. Now, we cannot do anything. Now, we have exhausted everything, supply side also satisfied. We can now of course the cross check that what is the situation. Patna is supplying 3,000. So, it is supplying 2,000 to Delhi, 1,000 to Kolkata. So, 2,000 plus 1,000, 3,000 correct. Similarly, Guwahati is supplying 2,000 to Lucknow, 4,000 to Delhi. So, that means total 6,000 correct. Mumbai is supplying 1,000 here, 3,000 here, so 4,000. Hyderabad is satisfying 1,000, 3,000, 1,000 to Chennai, like that 5,000. So, we check that supply side is okay. Lucknow needs 2,000, okay, it is getting 2,000. Delhi needs 7,000, 2, 4, 6,000, 7,000, like that you can cross check. Jaipur needs 4,000, so okay, it is getting from Mumbai 1,000, from Hyderabad 3,000, and therefore total is 4,000. And Chennai needs 1,000, it is getting entirely from Hyderabad, this is this one. And Kolkata needs 1,000, getting. Dummy cell needs 3,000, getting. Okay. See how many column cells are filled, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, you see the 9 cells are now filled. Okay. So, we have 9 cells, that means there are Patna, Guwahati, Mumbai, Hyderabad, 4 destinations, 4 suppliers, sources. Okay, we can say 4 sources, 4 sources, 4 sources plus destinations are 6, 4 plus 6, m plus n minus 1 is equal to 9. So, we need basically 9 basic variables. So, we are getting already by that one. So, we do not have to give maybe 0 something allocation to any cell, because here 1, 2, 3, 4, 5, 6, 7, 8, 9. So, we have this one, and total minimum transportation cost came out to be how much, 1060 into 2000 into 580 into this one, and we calculated that, and it is coming this much amount. Okay. How much? 2 crore and then 1 lakh 30,000. Okay. 2 crore, 1 lakh and 30,000. So, here we are seeing that it is getting the transportation cost which is more than the least cost method. Okay. So, it may happen sometime. Okay. So, that is what I am telling, that these are heuristic method. It is not this one, but of course, the north west cardinal method in fact give this thing. So, I think same cost. Okay. You can check it in my video, that means in 42nd lecture you can check, but it is like that. So, but these are heuristic methods. So, there is no guarantee, you can say most of the time it may happen, but it is like that. So, anyway, let me summarize that this method, Vogel approximation method, which was started by Vogel, and I have illustrated it. Now, I am writing in the words. VAM is an improved version of the least cost method that generally, but not always, produces better always produces better starting solution. So, not always. Okay. That is. So, for each row and column determine a penalty measure by subtracting the smallest unit cost in the row column from the next smallest unit cost in the same row and column. This penalty is actually a measure of lost opportunity one goes if the smaller unit cost cell is not chosen. Okay. That means, you have to say that you are missing the opportunity. Suppose some cost is in one cell, minimum cost is let us say 30, and after that in next one, next smallest is 31. So, hardly there is one difference. So, even if you do not allocate to 30, okay, you can allocate to 31, it will not make much difference, because the penalty is also less. But suppose least cost was 30 and after that next least cost was 60, then if you do not allocate anything to 30, then you have to allocate to another one, say 60, and therefore, it will be huge difference. That is why we do this. Identify the row or column with the largest penalty, breaking ties arbitrarily, allocate as much as possible to the variable with the least unit cost in the selected row or column, adjust the supply and demand, and cross cut the satisfied row or column. If a row and a column are satisfied simultaneously, only one of the two is crossed out and the remaining row column is assigned 0 supply demand, so that you do not get the problem of degeneracy. Now, third step is that if exactly one row or column with 0 supply or demand remains in crossed out, uncrossed out, then stop. Okay. One will remain of course uncrossed out, that as we did. And if one row column with positive supply demand remains uncrossed out, determine the basic variable in the row column by the least cost method. Okay. Suppose there is still some supply is needed, demand means something is not satisfied, then of course you can use. If all the uncrossed out rows and columns have 0 supply and determine the 0 basic variable by the least cost method and stop, otherwise go to step 1. So, here we just have written for to foresee some situation that suppose you are not able to do that by any penalty method, etc., because only say for example, in the situation C, if all the uncrossed out rows and columns have 0 supply and demand, okay, then determine the 0 basic variable where we should put by the least cost method. Okay. Otherwise, go to step 1, and this is based on the book of Taha, that this one. So, this problem we have done, and let us do that one more problem, okay, just to get more confidence, because in this method. So, suppose I have taken 4 sources are there, S1, S2, S3, S4, and demands are D1, D2, D3, D4, D5. Okay. So, basically we have 4 plus 5 minus 1, that means 8 basic variables we need. Supplies are given, demands are given. Total supply is how much? 30 plus 80, 110, 120, and then 130. So, the 40, this is 110, 120, 140, and demand 10, 50, 60, 28T, 40, 120, 20, 140. So, demand and supplies are balanced, we do not have to allocate any dummy row. Only thing that now we have to find out the penalty. So, cost per unit cost of transportations are given in the cells. Now, say for example, S1 row minimum least cost is 3, second least cost is 4 minus 3 is 1, S2 2, okay. So, 2 cells are having same, so penalty is 0, S3 is 0, S4 is 0, and here what happens in D1 it is 0, D2 0, because there are 2 cells which are having same least cost, okay. D3 0, D4 least cost is 3, second least cost is 4, so 4 minus 3 is 1, and D5 is 2 minus 2 0. So, here that type of situation has come. Penalty, what is the maximum penalty? It is at 2 places, either at S1 row or D4. So, you have to, so there is a tie, this tie you can break arbitrarily. That means, either you try to decide to supply everything to S1 row, or you can choose D4 column, whichever you want. Let us see what we have done. So, we have to do that like that, that is, suppose this is 1, and now we can give that allocation. So, this is, that is D4, and now here we can give the supplies, okay. Let me just see that here. So, this is like that, and this will be like this, and now here we can give the supply, okay. Demand is D4 is 40, okay, and this is 30, okay. So, like that, and this one. So, so therefore, remaining portion will be same, okay. That means, you will keep doing that, and let us see that another problem. Another problem is, suppose we have this type of thing, D1, D2 and D3, D4, D5, okay. So, here also we can have this one, okay. That means, here also we can find out the penalties, okay, and this is, these penalties are here 10 minus 2, 2, 2, and like that. So, here you can do the allocation that way, and you can actually do, I am just indicating, not completely solving the problem, I am just explaining. And suppose you have, okay. So, this is about this one, and now we may have to do that, say suppose S2 to D1, okay. Now, suppose we go to this one here, that destination, this is about D1, D2, D3, D4, and this is supply, and this is S1, S2, S3, S4, and we may have assigned that here. If we have assigned something 0, 0, 0 here, that cost, then naturally that there will be tendency to supply maximum unit to this, okay. So, therefore, what happens that here it is so similarly that you know that we can obtain adjust the penalties, okay. So, like that we are taking that different cases, okay, and we are doing that thing. So, it is about this one, and now it is so if we have just done about this one, so like that, okay. So, this is 10, 30, and you can, if you want to supply, if you want that you should maximum supply from one cell to the other cell, so then in that case that cost is allocated 0, okay. So, therefore, that type of thing is there, okay. Now here it is about this one. So, you can solve this problem. Suppose beginning problem I gave this one, and this problem where we are supplying these quantities, about this one 3 and this one, okay, that this is 3 and this is what about that this one. So, it is you can solve that, and you can say you note down this problem, okay. This is 3, this one, and here you have written the penalty. Now the supply etc. If you want to do that and you complete this problem, then it becomes the transportation cost becomes 3 into 10, 4 into 20, 20 into this, 4 into 20, 5 into 3, 3 into 20, 470. Okay. This becomes by Vogel approximation method. You know, final answer of that problem is given here. This is 10 and this is 20, this is I think 30, yes, this is 20. You can put it in circle 30, and then you can do 10, and then you can do 20. Okay. You can have this one. So let us see. I have this one. So how many? 1, 2, 3, 4, 5, 6, 7, and we need how many cells we need? We need that 4 plus 5 minus 1 is equal to, we need 8, but here we have filled up 3 to 5 to 7. So that means at one place you have to give some zero supply also. Okay. Maybe you can consider it is here. Okay. This is just dummy thing. Okay. So say 470. So this much you can do that. Okay. So these are the three methods you can practice. Vogel approximation method takes time. Okay. You have to do with patience, and you know, in between if you do small calculations, of course it will create problem. Northwest corner method is very easy. I can quickly do that thing, but we will now taking the initial solution from any of this method. Now we have to do what? Now we have to find optimum solution. So that I will be explaining now in the next class, and then this topic on the transportation model will be over. Thank you very much. Okay.